Hi students, welcome to Future Doctor NEET Academy for the crash course in physics, NEET Physics. Already we have completed chapter 6. Now chapter 7 we have to start today's session. Okay, chapter 7 title is Alternating Current, shortly called as AC current. What is alternating current? The current whose magnitude changes with time and direction reverses periodically is called alternating current. Okay, that is current whose magnitude changes with time and direction reverses periodically. 1 minute. So AC means current whose magnitude changes with time. See, when time changes, then magnitude also what's happening? From 0 it's increases to maximum and it reaches to 0. Again it increases to maximum in other direction, opposite direction. That is only magnitude changes with time continuously and direction reverses periodically is called alternating current. And same way alternating EMF and current I at any instant of time is given by E equal to E naught sin omega t, because we already studied that E equal to E naught sin omega t only. Here E is the EMF, E naught is the maximum value of the EMF or peak value or amplitude of the EMF, and sin omega t, that is it follows sine wave. Just like y equal to a sin omega t we studied, no? Y equal to a sin omega t in waves in 11th standard. That formula we are applying. Y equal to a sin omega t, y is a displacement, a is the amplitude and omega t, omega is the angular frequency, t is a time. Same like that here, E equal to E naught sin omega t. E is the EMF at t time and E naught is the peak EMF or amplitude of the EMF. What is amplitude? Maximum value. And here E naught equal to N.B.A. omega. E naught equal to N.B.A. omega that we studied in the previous chapter in alternating current in previous topic. And here E naught equal to N.B.A. omega and I equal to I naught sin omega t minus phi. Okay, I is the current at any instant of time equal to I naught peak value of current into sin omega t minus phi. Omega t is an angle that is equal to theta equal to omega t. What is phi? Phi is called, what is phi? Phi is a phase angle. Okay, phi is called phase angle. And here I naught equal to N.B.A. omega by R. What is N? N is the number of turns of coil. B, magnetic field or magnetic induction. A, area. Omega, angular frequency or resistance. And omega equal to 2 pi n. What is omega? Angular frequency equal to 2 pi into n. What is n? N is a frequency. N is the frequency, small n, that is capital N only, number of turns of coil, small n is the frequency. And frequency is nothing but reciprocal of time period. Okay, frequency is a reciprocal of time period, therefore omega equal to 2 pi n equal to 2 pi by t. Here t is the time period. Frequency is measured in hertz and time is measured in second and omega is measured in, what is the unit of omega? Angular frequency. What is the unit of angular frequency? It's radian per second. Note down. Okay. Omega is the angular frequency. Its unit is radian per second. N is the frequency in hertz. T is the time period in second. Okay. And what is E? E is the EMF. What is the unit of EMF? Unit of EMF? Volt. Okay, unit of EMF is volt. I is a current in ampere. Okay, noted, no? Noted, Sabrish? Can we move to next topic? Values of alternating current voltage. Instantaneous value. It is a value of alternating current and voltage at an instant of time, given instant of time. That is called instantaneous value. What is instantaneous value? Is a value of alternating current at a given instant of time. Alternating voltage means is a value of alternating voltage at a given instant of time. That is the instantaneous value of current or voltage. Peak value. Peak value is the maximum values of voltage E0 and current I0 in a cycle are called peak value. We used previous E0 and I0. E equal to E0 sin omega t. I equal to I0 sin omega t. That E0 I0 only peak value of EMF and peak value of current. Then mean value or average value. Mean value or average value for one complete cycle. That is E average equal to, this symbol is for average. It should be read as E within the bracket means E average. E average equal to 1 by T into integral of 0 to T E into dt equal to 0. Okay, that is the mean value or average value for complete cycle of EMF. E average equal to 1 by T into integral 0 to T E into dt equal to 0. Similarly, I average equal to 1 by T into integral 0 to T I into dt equal to 0. Okay. And mean value for off cycle E mean equal to 2 E naught by pi. Okay, 2 E naught by pi. What is here E naught? E naught is the peak value or maximum value of EMF for voltage divided by pi. 2 times of E naught by pi, that is equal to mean value for off cycle. One off cycle. Okay. Noted, no? Next, RMS value. RMS value or root mean square value. That is ERMS equal to E square average whole power 1 by 2, that is equal to E naught by root 2 equal to 0.707 times of E naught, that is 1 by root 2. What is the value of root 2? Root 2 equal to how much? 1.414. 1 by 4.414 is 0.707. Okay. So 1 by root 2 is 0.707. E naught equal to 70.7% of E naught. Percentage means into 100. 0.707 into 100, that is 70.7 E naught. Similarly, IRMS, that is a root mean square value of current, equal to I square average whole power 1 by 2 equal to I naught by root 2 equal to 1 by root 2 is 0.707 times of I naught multiplied by 100, then 70.7% of I naught. And here RMS value are also called as effective value or apparent values. Mostly effective value also will be used. RMS value is effective value or apparent values. So in problems and all we are going to discuss later, that is current ratings. For example, in our normal plug, 3-pin plug there and all, in this plug point, how much current, how much voltage is there? Can you say? In a normal plug, no? 5 amp plug. In the current value will be 5 ampere, voltage will be 220 volt. So that 5 ampere is IRMS value and 220 volt is ERMS value. Okay, ratings will be given in RMS value. Okay. Alternating EMF is that EMF which continuously changes in magnitude and periodically reverses its direction. And alternating current is that current which continuously changes in magnitude and periodically reverses its direction. So here this is EMF, alternating EMF and with current, with respect to current. And here is mentioned as I naught, E naught. Okay, that is I naught is represented in green curve and E naught is in blue color curve. And this is for sine curve, sine wave. And this is a cos curve, cos wave. That is E equal to E naught cos omega t, I equal to I naught cos omega t. What's the difference between these two curves? Both are looks like sinusoidal wave only, and this is sine wave. Sine wave means where's the value of sine 0? Sine 0, 0, 0. Start with 0. And what's the value of cos 0? 1. So at 0, it's having maximum value. Okay. So it looks like that. That is a cos wave. This is a cosine wave and this is a sine wave. And EI is the instance value of EMF and current. E naught, I naught, peak value or maximum value or amplitude. Already I said no, amplitude. Amplitude of EMF and current. Omega, angular frequency. T is the instantaneous time. And omega t is a phi, and omega t equal to phase, that is equal to theta, and phi will be a initial phase. Okay, that only used for phase angle and all. That's why I explained as just phase. Okay. Next. Average value or mean value of alternating current. That is a dq equal to I into dt and I naught into sine omega t dt. And integral of dq is q. Okay, integral of dq is q and I into dt, integral of dt. So integral 0 to t by 2, this is for one half cycle, 0 to t by 2, I naught sine omega t dt. And on substituting, we will get q equal to 2 I naught by omega. That is, here we will get 2 by omega will be answer, we will get here on integration. So 2 I naught by omega. And omega equal to 2 pi by t. Okay, omega equal to 2 pi by t, that we are substituting. So value of omega is 2 pi by t. Omega equal to 2 pi by t. That only we substituted. 2 pi by t is t by 2 pi. And this 2 getting cancelled. Then I naught t by pi. Then mean value of AC, that is I mean value or I average value equal to q by t by 2, and that gives 2 I naught by pi. And pi, what is the value of pi? 3.14. And 2 by 3.14, that will be 0.637. Therefore, I average equal to 0.637 I naught. And multiplied by 100, 63.7 percentage. For percentage, it should be into 100. Similarly, EMF, instead of I, it will be E. EM equal to E average equal to 2 E naught by pi equal to 0.637 E naught equal to 63.7 percentage of E naught. Okay. And average value or mean value of alternating current or EMF over a complete cycle is 0. Noted? Writing to Sabrish. And RMS value or effective value or virtual, it has different name, is the steady current which would produce the same heat in a given resistance in a given time as it produced by the alternating current in the same resistance in the same time. It will be compared with the heat energy, and that is the Joule's law of heating. dH equal to I square or T, that is the Joule's law of heating. That is Joule's law of heating, H equal to I square or T or into T. H equal to I square or T. And dH equal to means here time will be changing I square R into dt, and I equal to I naught sin omega t. Substitute that I naught square or sin square omega t into dt. Okay, and dt means we want to integrate. dH and dt means integrate to get t. Then integrate 0 to t I naught square or sin square omega t dt, and if you simplify this we will get 1 by 2. Therefore, I naught square or t into 1 by 2 as by 2, and that only. After integration, omega is replaced as 2 pi by t. Omega will get omega equal to 2 pi by t. You want to substitute and simplify, we will get these things. And IV is the virtual value of AC or RMS value of AC. RMS value we use or virtual value, anything can be said. And H equal to IV square or T. And here IV equal to IRMS equal to I effective equal to I naught by root 2. Question will be asked in our problem, that is IRMS value will be given, find the peak value of current. IRMS equal to I naught by root 2. So multiply by root 2 with IRMS, you will get I naught as peak EMF, peak current. So IV equal to IRMS equal to I effective equal to I naught by root 2. What is I naught? I naught is the peak value of current, equal to 1 by root 2 is 0.707. 0.707 I naught. 0.707 I naught equal to 70.7% of I naught. And RMS value or virtual or effective value of EMF. For EMF, EV instead of I, EV. EV equal to ERMS equal to E effective equal to E naught by root 2, 0.707 E naught equal to 70.7% of E naught. Okay, E naught is the peak value of EMF. And relative value, peak value and mean value of alternating EMF. Here is the diagram. Here E naught will be maximum value and EV, EM. Okay. See, I said no rating, 230 volt AC. Here in our plug, how much current will be means current will be in 5 ampere and voltage may be in 220 volt or 230 volts. Suppose if you are purchasing new plug, 3-pin plug like that means, then there will be a rating will be there, 230 volt or 220 volt. That rating is E effective value or ERMS value. Okay. By knowing the ERMS or E effective, you can find E naught. E naught value and E average value. Okay. Next. When AC current, that is when resistor is connected to AC, alternating current. This is a resistor, symbol for resistor, or when it is connected to or AC. This is a symbol for AC. What is the name of the symbol? It is a sinusoidal symbol. If it is like this, it is a AC. And if it is in DC, how it will be? DC will be like this. This is a DC. Okay. And AC means it will be simply like this. Sinusoidal voltage, just like this wave, shape of the wave. Okay. Sinus, it should be read as sinusoidal. Okay. And so if it is connected with like this, then it's a sinusoidal wave, that is called AC. Then when resistor is connected with alternating current, then and if the resistor is a pure resistor, then the voltage and the current are in the same phase. Okay, voltage and current are in the same phase. What is the same phase meaning? See, here voltage is represented in a blue color curve, is it so? And the current is represented in what color? Pink or brown? Oh, here it shows brown. Okay, the shading is pink. That this is brown only, no, this color. Okay, so voltage is represented in a blue color and current is represented in brown color. Okay, and see there, when time changes, when t increases, then both will starts at same phase as 0 and both will reaches the maximum at same time and reaches 0 at same time and also reaches negative maximum same time, reaches 0 same time. Okay, so both will reaches same time, that is why its phase, both are in same phase. What is phase? Define phase. Phase is the state of the wave. Okay, phase is the state of the wave which determines the position and direction of motion at a given instant of time. That is called phase. What is phase? Phase is the state of the wave which determines the position and direction of motion at a given instant of time. That is, at this time, where is that? What is the position? What is the direction? That will be represented by phase. Now, when AC current, when resistor is connected with AC current like this, then voltage and current are in same phase. Same phase means phase difference is 0. Phase difference is 0. That is, both will reaches maximum same time, reaches 0 same time, reaches negative maximum same time, reaches 0 same time. So, both are in same phase. Next, when AC is connected with inductor, this is a circuit symbol for inductor connected with the alternating current. V equal to V0 or Vm. We use V0 or Vm. Then for pure inductance, voltage is head of current by pi by 2. Voltage is a head of current by pi by 2. So, see in this graph, when current is 0, where is the voltage? Voltage will be maximum. Is it so? And when current reaches maximum, voltage comes to 0. And when current reaches 0, voltage reaches negative maximum. At any time, if you see, voltage is head of current by pi by 2, or current lags behind the voltage by pi by 2. Okay, voltage is head of current by pi by 2, or current lags behind the voltage by pi by 2. Then the phase difference between voltage and current is pi by 2. Phi is a phase equal to pi by 2. Okay. Okay, no. That is, when the resistor is connected with AC, then phase difference is 0. And when the resistor, that is when the inductor is connected in a AC, then phase difference is pi by 2. That is, voltage is head of current by pi by 2, or current lags behind the voltage by pi by 2. Okay. Next, resistor over, inductor over, what will be next? Three things are you studied already. Resistor completed, inductor completed. What is the next one? Capacitor. Capacitor. AC current connected through pure capacitor. Already we studied capacitance of a capacitor in electrostatics. Is it so? And when the AC voltage connected with a capacitor C. Then for pure capacitor, voltage lags behind the current by pi by 2. Voltage lags behind the current by pi by 2. See how is it? When voltage is 0, current is where? Pi by 2, plus pi by 2, maximum. And when voltage reaches maximum, current comes to 0. So always current will lead the voltage. So your voltage lags behind the current, or current leads the voltage by pi by 2. Okay. Lags behind means it's back. Current leads the voltage means current is front. As per the diagram, current is at front. So current leads the voltage by pi by 2. Then phase difference between voltage and current is minus pi by 2. This is phase difference between voltage and current is minus pi by 2. So just we will recall, when AC is connected through pure resistor, then how is the phase difference? 0. And when it is connected to inductor, pi by 2. And when it is connected with capacitor, minus pi by 2. Okay, minus pi by 2. So even in it, these questions are all asked as a theory part. Next, variation of XL with frequency. XL. What is XL? XL is the inductive reactance. It is a resistance only. It is a inductive reactance. Okay. XL is the inductive reactance. What is inductive reactance? It is a resistance offered due to inductor. That is called inductive reactance. And I naught equal to E naught by omega L and XL equal to omega L. Actually, I naught equal to E naught by XL. I naught equal to E naught by XL. XL is the inductive reactance and E naught by XL. And XL equal to omega L, we know omega equal to 2 pi N or 2 pi F. Frequency can be used as F or N or nu. Here we used frequency as F. So omega equal to 2 pi F. Substituting this, XL equal to 2 pi FL. That is, XL is directly proportional to F frequency because 2 pi is constant. 2 pi is constant and inductance value also constant. Then XL is directly proportional to frequency. So if it is directly proportional means how is that? When frequency increases, XL also increases. How? Linearly. Straight line means it will increases linearly. Okay. That's why XL is proportional to F. Then variation of XC with frequency. What is XC? Just like inductive reactance, can you name it? XL is the inductive reactance, then XC is? XL is called inductive reactance, XC is? C is a capacitor, then capacitive reactance. XC is the capacitive reactance. What is capacitive reactance? It is the resistance offered due to capacitor. Okay. What is a capacitive reactance? It is a resistance offered due to capacitor. And I naught equal to E naught into 1 by omega C. Actually, I naught equal to E naught by XC only. XC equal to 1 by omega C. Okay. And XC is the inductive reactance and omega equal to 2 pi F. And if you substitute this, XC equal to 1 by 2 pi into FC, or XC is proportional to 1 by F, or XC is inversely proportional to F. That is why when F increases, XC value increase or decrease as per the curve. When F increases, XC value decreases. Is it so? Its value decreases. That is why it's inversely proportional. Okay. Noted, no? Now, AC circuit with L, C or in series combination. Previously, we discussed AC circuit connected with first resistor R only. Second, AC circuit connected with inductance only, L. Third one, AC circuit connected with capacitor, C. Okay. Now, all the three are connected in series. And two more is there, AC circuit connected with LC only, AC circuit connected with CR only, AC circuit connected with L and R only. Like that also, three more combinations there. That's not in your syllabus. It's removed actually. Now, AC circuit with LC are connected in series. L, C or all are connected in series with AC, sinusoidal voltage. Then the applied EMF appears as voltage drops VR, VL, VC across RL or L and C. What is VR means? VR is a voltage drop across resistor and VL is voltage drop across inductor and VC is voltage drop across capacitor. Then already we studied that in or current and voltage are in same phase. What is the phase difference? Current and voltage are in same phase in connected with resistor. Then what is the phase difference? 0. Okay. And in inductor L, current lags behind the voltage or voltage leads the current by pi by 2. And in capacitor, current leads the voltage by pi by 2. And if you combine all the things, E equal to square root of VR square plus VL minus VC whole square. What is VR? VR is the voltage drop across resistor. Like this also one problem just recently we have done in our YouTube channel. VR is the voltage drop across resistor. VL is the voltage drop across inductor. VC is the voltage drop across capacitor. And in this, either this one and this one or this one. In these three, many times problems are asked repeatedly. Okay, note down this formula. E equal to square root of whole square root of VR square plus VL minus VC whole square, and we know formula I equal to E by R. Then I equal to E by square root of R square plus XL minus XC whole square. And from this square root of R square plus XL minus XC whole square is nothing but Z. What is Z? Z is called impedance. Z is called impedance. What is impedance? Impedance is the resistance offered due to resistor, capacitor and inductor combined one, that is called impedance. XL is the resistance offered due to inductor. XC is the resistance offered due to capacitor. Same way R is ohmic resistor. Then combining all the things we are calling impedance. What is impedance? Impedance is the resistance offered due to capacitor, inductor and resistor. All the three combined, no? Combined resistance only called as impedance. It is noted by symbol Z. Its unit is same as resistance. What is the unit of resistance? Unit of resistance. Yes, unit of resistance. Ohm. So impedance also same ohm. Okay. Then substitute that XL as 1 omega L and XC as 1 by omega C. Then Z equal to whole square root of R square plus omega L minus 1 by omega C whole power 2. And tan phi. Tan phi is a phase angle. Tan phi equal to XL minus XC by R. And substitute XL as omega L and omega C as XC means then tan phi equal to omega L minus 1 by omega C divided by R. And this is a graphical representation, that is for VR current and voltage same phase, voltage also same direction, current also same direction, so its phase angle is 0. And for inductor, voltage and current will be leads by pi by 2. Voltage and current leads by pi by 2. And for capacitor, current voltage lags behind the current by pi by 2. That is represented by this graph. And its effective resistance, that is VL minus VC along one side and VR along other side, means then total EMF, effective EMF E equal to square root of VR square plus VL minus VC whole square. That is, this direction of this value E will be given here in this graph. Okay. Can we move to next? And as we discussed already, tan phi equal to XL minus XC by R, or tan phi equal to omega L minus 1 by omega C by R. And special case, when XL is greater than XC, then omega L is greater than 1 by omega C, then tan phi is positive or phi is positive. Then here current lags behind the EMF by phase angle pi, and the LCR is inductance dominated circuit. Capacitor will be less dominant and XC will be dominated more. When XL is greater than XC, then it is the inductor dominated circuit. And when XL is less than XC, then tan phi is negative or phi is negative. Then current leads the EMF by phase angle phi, and it is a capacitance dominated circuit. And when XL equal to XC, what is XL? XL is the inductive reactance equal to XC. What is XC? Capacitive reactance. When these two are equal, then tan phi equal to 0 or phi is 0, then current and the EMF are in same phase. It means now the circuit is purely resistive circuit. Okay, it is a resistive circuit. Next, power in an AC circuit with LCR. E equal to E naught sin omega t. That's already we studied this formula. Same way, I equal to I naught sin omega t plus phi. This phi only we discussed as for resistor phi equal to 0, and for inductor phi equal to plus phi by 2, and for capacitor minus pi by 2. Okay, and here phi is the phase angle between EMF and current, and instantaneous power equal to E into I. Okay, power equal to voltage into current as E into I. Then substitute this E naught sin omega t into I naught sin omega t plus phi. Then E naught I naught take outside, then sin omega t plus phi, sin A plus B formula. Sin A into cos B plus cos A into sin B, and simplifying we are getting E naught I naught sin square omega t cos phi plus sin omega t cos phi. And if the instantaneous power is assumed to be constant for an infinitesimally small time dt, then work done is dW equal to E naught I naught sin square omega t cos phi plus sin omega t cos phi. And work done over a complete cycle, that is the energy you spend. W equal to integral 0 to t E naught I naught into sin square omega t cos phi plus sin omega t cos phi into dt. And if we integrate this, simplify integrate, we will get W equal to E naught I naught cos phi into t by 2. And average power over a cycle, P average equal to work done by time. Okay, and substitute this P average equal to E naught I naught by 2 into cos phi, and here cos phi equal to R by Z. And cos phi is another important one, that is called power factor. Like this also some problem will be asked. Cos phi power factor, and P average equal to E naught I naught divided by 2 into cos phi, and here cos phi is called power factor, and you want to represent in terms of ERMS, like that means E naught I naught by root 2 into root 2 as E naught by root 2 I naught by root 2, and E naught by root 2 I naught by root 2 as P average equal to EV into IV into cos phi. Remember, cos phi is called power factor. Okay. Transformer. The transformer already we discussed in previous chapter slightly, and here we will discuss once more. Transformer is a device which converts lower alternating voltage at higher current into higher alternating voltage at lower current. Simply, what is transformer? It transfers low voltage to high voltage or high voltage to low voltage. For example, you are using mobile now and you are charging the mobile. Okay, and in mobile, how much voltage it may require? Can you say? Already I said in our 3-pin plug holder, the 220 volt I said, 220 volt or 230 volt. And directly the 220 or 230 volt if you give to our mobile, then mobile will be burst, high voltage. So how much voltage it may require? Can you say approximately? Maybe in less than 25 maybe. Okay, around 25 or 12 volts, 15 volts, that's sufficient. So there will be one type of transformer is present in the plug holder we are having no in there, that is it contains transformer. What type of transformer means? Step down transformer. That is 220 volt is reduced to 20 volt or 24 volt or 15 volt. Okay, that is a step down transformer. So transformer is a device which converts high voltage to low voltage there, or low voltage to high voltage. Suppose in our area there will be a voltage problem, that is after 6 p.m. voltage drop is there. If it happens like that, then what we will do? We will ask, we will give a request to the EB. Then if more number of person will give request like that, means then they will install one transformer there. That transformer is a step up transformer. Okay, it is a step up transformer. It converts low voltage to high voltage. Okay, so principle used in transformer is based on mutual induction, and it is a phenomenon of inducing EMF in the secondary coil due to change in current in the primary coil, and there is a change in magnetic flux in the secondary coil. Already in mutual inductance we discussed. There itself I said this is the principle for transformer. That is phenomenon of inducing EMF in the secondary coil when there is a changing current in the first coil, that is primary coil. And what type of voltage this is? AC or DC? AC. What is the name of this signal? Sinusoidal signal or sinusoidal wave. Okay, and here when AC only, there will be a change in the direction continuously. And suppose instead of AC, if you use DC, then what will happen? Suppose if you use DC instead of AC, actually this is a AC, instead of AC, if you use a DC, then is it possible to get the current other side as increasing voltage or decreasing voltage? Not possible. That is, as per our electromagnetic induction, whenever there is a change in the magnetic flux linked with the coil, then only EMF is induced in the neighboring coil. Okay, so by changing the current only, magnetic flux linked with the coil will change. So we can't use DC for transformer. Okay, only AC can be used. And theory, EP or E1 will be used equal to N into d phi by dt, and ES equal to minus NS into d phi by dt, and ES by EP equal to NS by NP equal to K. This also we discussed in previous, where K is called transformer ratio of turns ratio. Okay, transformer ratio or turns ratio. And for ideal transformer, output power equal to input power. Ideal transformer, output power equal to input power. ES into IS equal to EP into IP. What is ES? ES is the voltage in secondary. IS, current in the secondary. And EP is the voltage in primary coil. IP, current in the primary coil. Then ES by EP equal to IP by IS. And ES by EP equal to IP by IS equal to NS by NP. And efficiency of a transformer. General formula for efficiency is efficiency equal to output power by input power. Efficiency eta equal to output power by input power. output power is ES into IS, and input power is EP into IP. In this also we will do some problems. Okay. And for an ideal transformer, eta is 100%. It means output power equal to input power for ideal transformer. But practical transformer, that's not possible. Only for ideal transformer only, output power and input power will be equal. So eta value will be 1 or 100%. Okay. Next. Step up transformer, I said no, number of turns. Actually step up means what? It converts low voltage to high or high to low? Low to high. Is it so? Low voltage to high voltage. How it will be possible? By changing the number of turns. See, in primary coil, number of turns is less. Wait, I will take highlight. So in primary coil, number of turns is very, very less, 1, 2, 3 turns only. In secondary coil, more number of turns, 1, 2, 3, 4, 5 number of turns. So by increasing the number of turns of the coil, it is possible to increase the voltage. And here, see, number of turns in secondary is greater than number of turns in primary, or ES is greater than EP, and for current reverse, IS is less than IP. Then step down transformer. Step down transformer means, what is it? Device which converts high voltage to low voltage. This only we are using in our mobile. And so here number of turns in the primary is greater than number of turns in the secondary. That is NP is greater than NS, or ES is less than EP. And K, what is K? K is called transformer ratio is less than 1. And IS is greater than IP. And some of the energy losses in transformer. Copper loss. Copper loss is ET is produced due to the resistance of the copper windings of primary and secondary coil when current flows through them. That is, small amount of heat will be dissipated. The dissipation of heat energy, that loss only we are calling copper loss. Okay, heat is produced due to resistance of the copper windings of primary and secondary coil when current flows through them, and it can be avoided by using thick wire. Already we discussed that if thick wire means its resistance will be increased or decreased. If you increase the thickness of the wire, resistance will be increased or decreased. Yes? Or is proportional to L by A. And for transformer action, resistance should be increased or decreases for good transformer. For good transformer, for example, step down. Step down means here 220 volt to here, example I am writing 15 volt. Okay. And for good transformer, it should possess high resistance or low resistance. Low resistance. Then only required voltage we will get. Okay. Then, so here A is the thickness of the wire, area of cross section of the wire, or thickness. If you increase the thickness, resistance will be reduced. That's why we said thick wire. If you use thick wire, then dissipation of heat energy due to resistance will be reduced. That's why, how can we avoid copper loss? By using thick wire for windings. Instead of thin wire, thick wire can be used. Next, flux loss. In actual transformer, coupling between primary and secondary coil is not perfect. So, certain amount of magnetic flux is wasted. Linking can be maximized by winding the coils over one another. By winding one coil over one another coil, we can maximize the linking, flux linking, to avoid flux loss. Okay. Next to loss, iron loss. Iron loss is classified into two: eddy current loss and hysteresis loss. Eddy current loss, when a change in magnetic flux, when a change in magnetic flux is linked with the iron core, eddy currents are set up which in turn produce heat energy, and that heat energy is wasted. And eddy currents are reduced by using laminated core. Yes, this is a core, sheets, and each will be laminated with one another. Okay, by laminating with thin sheets, then we can reduce the eddy current. Hysteresis loss. When alternating current is passed, the iron core is magnetized and demagnetized repeatedly. But already we studied that soft iron only mostly will be used. Soft iron is nothing but it is a permanent magnet or temporary magnet, soft iron. Steel is a permanent magnet. Soft iron is a temporary magnet. That's why we are calling electromagnet. Soft iron is an electromagnet. Steel is a permanent magnet. Okay. So while passing current, it will retain magnetism. When current is switched off or change in the value of the current, then what will happen? It will, by changing the direction of current, then direction will be changing. At that time, it will be magnetized and demagnetized. Okay. So by changing the magnetized and demagnetized means magnetism will be increased. Demagnetized means removal of magnetism. That is a demagnetized. Okay. So demagnetized, and during magnetization and demagnetization cycle, some energy will be wasted, loss. That loss only hysteresis loss. That is only hysteresis loss. And this can be minimized by using suitable material within thin hysteresis loop. And some alloys will be used. Next, losses due to vibration of core. This in normal transformer we can't observe, but in street area transformer, there we may observe some vibration. Okay, some electric energy is lost in the form of mechanical energy due to the vibration of core, and the humming noise due to magnetostriction effect. This magnetostriction effect is nothing but very important effect for the production of ultrasonics. Okay, for ultrasonics, magnetostriction effect is used. That is, whenever that ferromagnetic material is magnetized, there will be a change in the dimension of the material. That is, expansion and contraction takes place. That ferromagnetic material expanded slightly and contracts slightly. That is a vibration. During that vibration, it produces ultrasonics. That is called magnetostriction effect. So during this magnetostriction effect, here some amount of energy will be lost. And AC generator, that is previous chapter we discussed. What is generator? Generator is a device which converts mechanical energy into electrical energy. And we discussed different parts also, as electromagnet, brushes, split ring, like that. Field magnet, armature, slip rings, brushes, load, etc. And the direction of current can be measured by using Fleming's right hand rule, and each tone, for each tone or each angle, how is the current will flow. That is a positive direction and negative direction, it will flow like this. That will be explained. And theory is phi equal to N.B.A cos theta and theta equal to omega t. Therefore, phi equal to N.B.A cos omega t. Then d phi by dt. What is phi? Phi is a magnetic flux. This we studied in previous chapter. D phi by dt, and here change in orientation of the coil takes place, because that is, the current will flow in one direction and in another direction, like that. Orientation of the coil takes place. So this is the orientation by changing. One particular time, PQ will be top, SR will be bottom. Other time, SR will be top and bottom. That is a rotation. So by changing the orientation, omega t will be changing. Therefore, E equal to N.B.A omega sin omega t, and N.B.A omega equal to E naught, and E naught equal to N.B.A omega. That is the peak value of the EMF. So that is a E naught here. Okay. Okay. So one chapter over. We'll move to next chapter. Electromagnetic waves. This is a small chapter. After this chapter, we will give one break. Chapter 8, electromagnetic waves. What are electromagnetic waves? How electromagnetic waves are produced? That is the source of electromagnetic waves. Through accelerating charges. When charges are accelerated, charges moves with certain velocity and the speed is increases, that is only acceleration. When charges accelerate, electromagnetic waves are produced. And through oscillating electric dipoles. When dipoles oscillate, then electromagnetic waves are produced. And by harmonically oscillating electric charges. Harmonically means with constant frequency. That is harmonically oscillating electric charges, electromagnetic waves are produced. And oscillating fields of electromagnetic waves can accelerate charges and can produce oscillating currents. Okay. And electromagnetic waves in interaction with matter interacts through its electric and magnetic field which set in oscillating charges present in all matter. Mechanism of absorption and scattering depends on the wavelength of electromagnetic wave, nature of the atoms, that is the nature of the material, and molecules in the medium. Depends upon that there will be absorption or scattering of the electromagnetic waves takes place. And this is the electromagnetic wave. That is, wave is moving along x-axis. Example I am saying. Okay. Can you say any one example for electromagnetic wave? Some 7 electromagnetic waves are there. Can you say any one example of electromagnetic wave? Yes. Radio wave? Microwave? Yes, like that. Even light is a electromagnetic wave. Okay. I expected light. Okay, no problem. So, electromagnetic wave is a wave in which electric and magnetic fields are perpendicular to each other. That is, electric field act in which direction? Which axis? Y-axis. Electric field is acting in y-axis and magnetic field is acting in which axis? Z-axis. And waves will move in x-axis. These three are mutually perpendicular. That is, electric field is along y-axis and magnetic field is along z-axis, perpendicular. And waves will propagate in x-axis. That is the electromagnetic wave. And variation in both electric and magnetic fields occurs simultaneously. Variation means when electric field reaches maximum E0, then at the same time magnetic field reaches maximum B0. Then what is the phase difference? Like this also one time question will be asked. What is the phase difference between E and B for electromagnetic waves? Both will reach as maximum at the same time, both will reach as 0 at the same time. Then what is the phase difference? 0, because both are in phase, same phase. Therefore, phase difference between electric and magnetic field is 0. That's why we said both will reach as maxima and minima at the same place and at the same time. That is only phase. And the direction of electric and magnetic fields are mutually perpendicular to each other. That only I said, and as well as direction of propagation of wave. Wave will propagate in x-axis and magnetic field and electric field in z and y-axis. Then electric field vector E and magnetic field vector B are related by C equal to E0 by B0. Here what is C? C is the speed of light and E0, B0 are the maximum or amplitude of the electric and magnetic fields or peak value of the electric and magnetic fields. So, C equal to E0 by B0 is the important formula. C equal to E0 by B0 is a very, very important formula to determine the velocity of the electromagnetic waves. The velocity of electromagnetic waves in free space is C equal to 1 by root of mu naught epsilon naught. What is mu naught? permeability of a free space or vacuum, value 4 pi into 10 power minus 7 Henry per meter. And epsilon naught is the permittivity of a free space or vacuum, value 8.8 into 10 power minus 12. And fifth point, the velocity of electromagnetic waves in a material medium is equal to 1 by square root of mu epsilon. Velocity of electromagnetic wave in a medium. This is in free space or air medium. This is the formula. In a medium means 1 by square root of mu into epsilon. What is mu and epsilon? Is the absolute permeability and absolute permittivity, or permittivity of the medium and permeability of the medium and permittivity of the medium. Okay. And electromagnetic waves obey the superposition principle like normal light. And electromagnetic waves carry energy as they propagate through space. This energy is divided equally between electric and magnetic field. That is why we are using this as a carrier wave in modulation. In electronics, modulation is a very, very important topic to transfer the signal from one place to other place. So there, this electromagnetic wave acts as a carrier wave. It transmits energy from one place to other place. And electromagnetic waves can transfer energy as well as momentum to objects placed on their path. For discussion of optical effects of electromagnetic wave, more significance is given to electric field E. Compare with electric and magnetic field, electric field is having more significance. So, electric field is called as light vector. And electromagnetic waves do not require material medium to travel. That you studied in wave motion, I think, waves and wave motion in +1. That is basically waves are classified into two. One is mechanical wave, another one non-mechanical wave or radio wave or electromagnetic wave. That is, what is electromagnetic wave? It does not require material medium for propagation. And an oscillating charge which has non-zero acceleration can produce electromagnetic wave. That already we discussed. That is, the charges are oscillating or accelerated, it produces electromagnetic waves. Maxwell's equation. Actually, for each there is a proof is there, for you just a statement or formula. First Maxwell equation, closed integral E dot dA equal to Q by epsilon naught. And E dot dA is nothing but flux, magnetic flux, phi. E is the electric field, dA is the area. And Q, what is Q? Q is a charge. Epsilon naught, permittivity of a free space or vacuum. And this formula is from Gauss law of electrostatics. This is from Gauss law of electrostatics. Second one, closed integral B dot dA equal to 0. B is a magnetic induction or magnetic field, dA area, enclosed area, and that is equal to 0. That is a Gauss law of magnetism. Gauss law in magnetism. And third one, closed integral E dot dl equal to minus d phi by dt of B. B represents it is a magnetic flux. Okay, phi B means it is a magnetic flux. B is a magnetic field. So, closed integral E dot dl equal to minus d phi by dt, and it is the Faraday's laws of EMI. What is EMI? What is EMI? Electromagnetic induction. Yesterday only we discussed this chapter. Faraday's laws of electromagnetic induction. And closed integral B dot dl equal to mu naught into IC plus epsilon naught into d phi E by dt. This d phi E represent, it is the electric flux. Phi B represent magnetic flux and phi E represent electric flux. Okay. Phi E represent electric flux. And what is IC? IC is the conducting current. IC is the conducting current, and this is from Maxwell Ampere circuital theorem. This is the Maxwell-Ampere circuital theorem. And these equations express all basic laws of electromagnetism. Just like Newton's law of motion, 3 Newton's law of motion is very important for mechanics. Just like that, Maxwell equation is very, very important for electromagnetism or electromagnetic theory or electromagnetic field theory, EMT, called as EMT, electromagnetic theory or field theory. That is very, very important paper, separate paper, probably in 4th semester in engineering ECE students, that is electronics and communication engineering students, and EEE students, electrical and electronics engineering students. These two students are studying EMT or field theory or electromagnetic theory as a separate paper, feeling as a toughest paper for them. And for that paper, these 4 equation is a basic equation. Okay. And these are the electromagnetic waves or electromagnetic spectrum. I said no, 7 electromagnetic spectrum, 1, 2, 3, 4 and 5, 6, 7. And first one, electromagnetic waves, radio waves. Range of wavelength, few kilometer to 0.3 meter. You are able to see the few kilometer to 0.3 meter. That is the wavelength. And range of frequency, few hertz to 10 power 9 hertz. Source, how these radio waves can be produced? By oscillating electronic circuits. By oscillating electronic circuits, we will oscillating electronic circuits. Uses, application, radio waves and TV broadcasting, that is in communication. Satellite communication uses these radio waves. Live telecast, no, that uses radio waves. Microwave, wavelength range 0.3 meter to 10 power minus 3 meter, and its frequency 10 power 9 hertz to 3 into 10 power 11 hertz. Source, oscillating electronic circuits. Application used in radar. What is radar? Expand radar. Yes. Suppose any flight or any ship is coming inside our border, our nation border, it will be given alarm by a radar. Expansion of radar. Radio detection and ranging, that is called radar. And analysis of fine details of atomic and molecular structure. Atomic structure, molecular structure in a compound can be measured using microwave. And also another important one, microwave oven. Infrared wave, that is 10 power minus 3 meter to 10 power minus 7 meter. 7.8, 10 power minus 7 meter. And its range of frequency is 3 into 10 power 11 hertz to 4 into 10 power 14 hertz. Source is molecules and hot bodies. And very, very important property for infrared waves is it produces heating effect. It produces heating effect. Infrared, light or visible spectrum, and UV. These 3 are present in our sunlight. Okay. And if we remove IR, infrared waves, then we will not feel any heating effect in sunlight. So heating effect is because of, actually IR waves contains heating effect. And its source is molecules and hot bodies. And uses is used in industry, in medicine, actually sudden cramp. In Tamil we are calling suluku, sprains. For that we are using infrared. Infrared IR torch will be there. It produces intense heating effect, and if you suppose our hand is under sprain, suluku, then bring that IR radiation there for some time, it dilate the muscle. Muscular contract, muscular cramp only, because of that only that cramp will occurs. And when IR infrared radiation is falls on that, then it will expand the muscles, and therefore it will change the normal tissues, normal muscles. And astronomy, actually in infrared telescope is there. In night and all, we will use that infrared telescope, that is in astronomy. And night vision device, in night we want to take photograph or video camera, then instead of ordinary light we can use IR, infrared light. We can't see the infrared light, but it will sense and it will take the photo. And greenhouse effect is due to infrared. And our next slide I think I am showing. Okay. And why I try to show means heating effect, I said no. That is called one type of LED, that is called IR LED. Where we are using IR LED, infrared LED. Infrared LED. In our remote one corner, it contains infrared LED. Here, this is LED, infrared LED. Okay. And when we press this, infrared light is going and it only activates the sensor. Okay. That light we can't see. And revealing secret writings. For secret writings, infrared light will be used on ancient walls. And light or visible spectrum, 7.8 into 10 power minus 7 meter to 3.8 into 10 power minus 7 meter. Frequency 4 into 10 power 14 Hz to 8 into 10 power 14 Hz. Atoms and molecules, when electrons are excited, is the source. That is a laser. There we are using this. Laser, we are studying this. Atoms or molecule goes to excited state, and when it moves from excited state to ground state, it emits energy, light energy. Uses optics. What is optics? Optics is a branch of physics that deals about light. Optical instruments. What is the optical instruments? Can you say any optical instruments? Yes? Any one optical instruments? Microscope is an optical instrument. Telescope is an optical instrument. Is it so? Camera is an optical instrument. Our eye is an optical instrument. Vision, that only I said vision is eye. Photography. Photography with light only. That's all up to this. And fifth one, ultraviolet rays, UV rays. Range 3.8 into 10 power minus 7 meter to 6 into 10 power minus 10 meter. Range 8 into 10 power 14 Hz to 3 into 10 power 17 Hz frequency. Source, atoms and molecules in electrical discharges and sun. I said no, sun is a source for all these three, infrared light, visible light and UV light. And UV light is filtered in which area? UV light is filtered by one particular layer, ozone layer. Okay. Uses, medical application, that is in sterilization, killing bacteria and germs. That is our MRCOG, that and all fitted with this ultraviolet radiation, UV radiation. And germs in foodstuff, detection of invisible writing, forged document, that is a fake forged document, that is a forged note, that and all can be found using this, fingerprint, etc. We use UV rays. X-rays, range of wavelength 10 power minus 9 meter to 10 power minus 12 meter. Frequency range 3 into 10 power 17 Hz to 5 into 10 power 19 Hz. Source, inner or more tightly bound electrons in atoms. That is inside a cooled tube we are getting. And uses, X-ray photography. Our bone fracture can be detected using X-rays. Treatment of cancer. Cancer can be treated using X-rays. Skin disease can be used X-rays. Tumor. Tumor is a That is also one type of cancer. Locating cracks and flaws in finished metallic objects, that we are calling very, very important topic, that is called NDT. That is a non-destructive testing. It's a separate important chapter for civil engineering. That for example, old buildings and all there, that strength of the material can be detected using NDT. NDT means non-destructive testing. Okay. For example, that particular wall or particular roof, whether it is strong or not, without breaking, we have to find out. That is called non-destructive testing. So there X-rays will be used. X-rays will be used, ultrasonics also will be used. And cracks and flaws. Flaws means damaged one. In finished metallic objects, detection of smuggled goods in bags. In airport, railway station and all, no, there will be we have to keep our suitcase, it will move and it will be scanned. That is the X-rays. Study of crystal structure, that is using X-ray. Actually, I completed my PhD in here this topic only, that is called X-ray crystallography. Crystallography. So using crystal, X-ray only, crystal can be analyzed and we solved the structure and we found the atoms or solved that one. Okay, that is called crystal structure X-ray crystallography. And last one, gamma rays. They overlap the upper limit of the X-ray, that is 10 power minus 10 meter to 10 power minus 14 meter. Frequency range 3 into 10 power 18 Hz to 3 into 10 power 22 Hz. Source, radioactive substance. In nuclear physics we will study radioactive substances. Uses, application, information about structure of nuclei. Okay, structure of nuclei, how many protons are there, how many neutrons are there, that can be studied using gamma rays. And astronomical resistance, that is called gamma ray telescope. X-ray telescope is there, gamma ray telescope is there, that is mostly that black hole supernova explosion, that and all can be photographed using powerful telescope, that is gamma ray telescope, X-ray telescope only. Okay, thank you students for completing these two chapters. Okay, now we will have a small break. After 10 minutes we will continue next chapter. Next chapter will be chapter 9, Ray Optics and Optical Instruments, that will continue after 10 minutes break. So be Okay, we'll start. Welcome back to physics, NEET physics crash course. Now chapter 9, Ray Optics and Optical Instruments. Already we have discussed that optics. What is optics? Optics is a branch of physics that is about light, studies about light. Okay, ray optics and optical instruments. So light in the form of ray means it undergoes some reflection, refraction, like that it follows some of the properties. Important property is reflection. Light undergoes reflection. What is reflection? Bouncing back of light rays, that is called reflection. And see, AO is the incident ray and OB is the reflected ray. Okay, so this is the incident and this is the reflected. This bouncing back of light. AO is incident and coming back as OB, reflected. That is called reflection. Bouncing back of light rays is called reflection. And laws of reflection. That is, the reflection at a plane surface always takes place in accordance with the following two laws. First law, the incident ray. AO is the incident ray and OB is the reflected ray and ON is the normal to the point of incidence, ON. All lie in the same plane, MOM plane, M1, O, M2 plane. The incident ray, AO, the reflected ray, OB, and the normal ON all lie in the same plane. This is the first laws of reflection. Okay. And second law, the angle of incidence I is equal to the angle of reflection R. I is the angle of incidence. What is angle of incidence? Angle of incidence is the angle between the incident ray and the normal. Okay. What is the angle of incidence I? Is the angle between the incident ray and the normal. That is called angle of incidence. And angle of reflection, the angle between the reflected ray and the normal. That is the angle of reflection. And angle of incidence equal to angle of reflection always. This is the second law of reflection. State first law, the incident ray, the reflected ray and the normal to the point of incidence all lie in the same plane. This is first laws of reflection. Second law, angle of incidence is equal to angle of reflection. I equal to R. Angle I equal to angle R. Suppose angle of incidence is 30 degree, then angle of reflection also 30 degree. Suppose angle of reflection is 90 degree, then angle of incidence also 90. Formation of image by the plane mirror. Actually, reflection will take place in a mirror, plane mirror only. Formation of image of a point object O by a plane mirror is represented in this diagram. The image formed I is the image formed and O is the object. O is the object and I is the image. Then it has following characteristics. Size of the image is equal to size of the object. What is the object size? Same size only, image size. Suppose if you see through the mirror, then if you see your face in the mirror, then your face is not appears as bigger or small size. It's same as it is. Same as object size. That only object size and image size will be same. And object distance is equal to image distance. Suppose you are 1 meter from the mirror, then image also will be appears as 1 meter. Or 2 centimeter from the mirror, it will appears image also 2 centimeter. Object distance OM is equal to image distance MI. And image is virtual and direct. What is virtual? What is virtual image? Yes? What is real image? Opposite of real only, virtual. Okay. Opposite of real image is virtual image. Simply if you want to say means a real image means image which can be obtained on the screen. If you are able to obtain the image on the screen, that is called real image, and which cannot be obtained on the screen is called virtual image. Okay. And erect. What is erect meaning? Erect. Erect means where is the wait, I'll change the color. Wait, color is not changed. So that is image is virtual and erect. Virtual I said erect. For example, image is like this. Then, so object is like this, and image also like this same. And suppose image is here like this, object is like this, and image obtained is like this. What is the name of this? This is only erect. This is inverted image. Image is inverted. In some time, if you see through lens, it will appear as an inverted image. Okay. And sometimes same as it is, that only erect. Erect means same, not inverted. That is erect. Okay. Suppose person is standing like this, because arrow means you can't obtain, and here it will be same. Okay. And when a mirror is rotated through a certain angle, then the reflected ray is rotated through twice the angle. Okay. For example, if the mirror is rotated through 30-degree angle, means reflected ray will be 30 into 2, 60-degree angle, twice of that. Reflection of light from spherical mirror. So far we have discussed this plane mirror, normal mirror. Now spherical mirror. Spherical mirror, two types, concave mirror and convex mirror. Okay, concave mirror, this is the coated surface, and this side only we are going to looking through this. Okay. And so this is a concave mirror and this is convex mirror. A spherical mirror is a part cut from hollow sphere. That is, this is a sphere. In the sphere, small cut and remove the small part. That only spherical mirror. Okay, maybe a concave or convex. And if it is coated this side, then it will be concave, and coated this side means it will be concave. Concave and convex. And they are generally constructed from glass, normal glass only. These are generally constructed, made from a glass. The reflection at spherical mirror also takes place in accordance with the laws of reflection. Reflection at spherical mirror is same as it is in plane mirror. So here also it also obey laws of reflection. Incident ray, reflected ray, and normal all lie in same plane. Angle of incidence is equal to angle of reflection, like that. It is accordance with the laws of reflection for a plane mirror. And here f equal to r by 2. What is r? R is the radius of curvature, and f is the focal length that we are going to discuss. And what is r? R is the radius of curvature. That is, if this is a curve and if you extend this, what you will get? You will get a circle. Is it so? Circle. Then for a circle from center to this, that is called r, radius of curvature. That is r. So f equal to r by f. And light rays will be incident on a concave mirror and will be focused at a particular point. This point is called F, that is called principal focus. This is called principal focus. And distance between focus and P. What is P means? P is a pole of the mirror. Distance between the principal focus and pole of the mirror, that is only focal length F. Okay. What is F? F is a focal length, distance between the principal focus and the pole of the mirror. And this F is equal to R by 2. Same thing for convex mirror. And here this is concave and this is convex. Sign convention. In sign convention, all distances measured in the same direction as incident ray are taken as positive, and those measured in the direction opposite of incident ray are taken as negative. That is, suppose light is moving this direction and we are measuring this distance, object is here, measuring the object from here to here, then that will be positive, and image will be obtained in the same side, opposite side. That is, the incident light will be in this direction and reflected will be in opposite direction. So, this distance measured now from F to P, that will be in negative. So, when you measure the distance, as same side of the incident ray will be taken as positive, opposite direction as negative, or right hand side will be positive, left hand side will be negative. Okay. See, here distance against incident light is negative, left hand side, and distance along the incident light, it will be taken as positive. Okay, this is positive, and here this side means negative. Same way height taken above the principal axis, this is only principal axis. This line is the principal axis. And above the plane mirror, sorry, above the axis, that is called positive. 1 minute. So, this is the principal axis. And height taken above the principal axis will be taken as positive. So, this will be taken as positive. And below the plane mirror, that principal axis, that is the inverted image, then it is negative. Okay. And as we discussed, focal length of spherical mirror, distance between the principal focus and the P pole of the mirror. This measurement only give focal length. This is the focal length of the mirror, and this focal length is equal to half of radius of curvature of the curved spherical mirror. This focal length F is equal to half of the radius of curvature, that only R by 2 we said, and this is for concave and this is for convex. Okay. Next, principal axis of the mirror that we discussed. Straight line joining the pole and the center of curvature. See, straight line joining the pole and the center of curvature, this is only principal axis. Straight line joining the pole and the center of curvature of the spherical mirror, extended on both sides is called principal axis of the mirror. And mirror formula is 1 by F equal to 1 by U plus 1 by V. 1 by F equal to 1 by U plus 1 by V. What is F? F is the focal length of the mirror. U is the object distance. V, image distance, shortly. Here U is the distance of object from the pole of the mirror, that shortly object distance. And V is the distance of image from the pole of the mirror, that is image distance. And this is the mirror formula. 1 by F equal to 1 by U plus 1 by V. And already we discussed that F equal to R by 2, there we used previously capital R or small r, that is the radius of curvature of the mirror. R is called radius of curvature of the mirror. Noted, no? Magnification. Magnification is defined as the ratio of the size of the image to that of the object. Magnification is the ratio of the size of the image to that of the object. And linear magnification, M equal to I by O, image by object generally, and V by U. V is the object image distance, U is the object distance. And here I is the size of the image, O is the size of the object. M equal to I by O or V by U. And this V by U you can write as F minus UV by F or F by F minus U. From the previous formula, we derived that. What is the mirror formula? 1 by F equal to 1 by U plus 1 by V. And in there, substitute V equal to, simplify for V and substitute this V value here, then you will get F by F minus U. Similarly, if you substitute U value there, then you will get F minus V by F from this formula. Okay. 1 by F equal to 1 by U plus 1 by V. In there, 1 by U equal to means, example, one thing I am writing, 1 by U equal to 1 by F minus 1 by V. Then U equal to, formula will come. Substitute this U equal to here, then you will get this formula, F minus V by F. Same way, simplify for V and substitute V value there, you will get F by F minus U formula. Okay. And magnification M is positive, implies that the image is real and inverted. This we discussed. Real image is, magnification M is positive means image is a real image and inverted image obtained. And if magnification M is negative, that implies that image is virtual and direct. Virtual means it is not a real image, and direct, it is not an inverted one. Refraction. So far we have discussed is reflection, one of the properties of light. Another property, refraction. What is refraction? When a light falls on the boundary separating the two media, there is a change in the direction of ray. That is called refraction, or change in direction of the light ray when it moves from one transparent medium to another transparent medium. See here, OA is the incident ray and another medium OB, refracted ray. What will happen? There will be a change in direction. That change in direction in the one transparent medium to another transparent medium is called refraction. When a ray of light falls on the boundary separating the two media, there is a change in the direction of ray. This phenomenon is called refraction. Laws of refraction. The incident ray, the refracted ray, and normal to the point of incidence all lie in one plane. That is called laws of refraction. Incident ray OA. OA is the incident ray, and refracted ray OB, and normal to the point of incidence all lie in the same plane. That is the first laws of refraction. It is same as first laws of reflection. And second law, for the same pair of media and the same color of light, the ratio of sine of the angle of incidence to the sine of the angle of refraction is constant. Sin I by sin R equal to constant. That constant is mu BA. Here mu BA is a constant known as refractive index of the medium B medium with respect to A medium. Okay. This is the refractive index of the B medium with respect to A medium, and I is the angle of incidence in medium A and R is the angle of refraction in medium B. I is the angle of incidence in medium A and R is the angle of refraction in medium B. And sin I by sin R equal to mu. This is the loss of refraction. Second loss of refraction. What is the other name of second loss of refraction means? That is Snell's law of refraction. Snell's law of refraction. And the exact definition for Snell's law is nothing but ratio between the sine of the angle of incidence to the sine of the angle of refraction is equal to refractive index of the second medium with respect to first medium. That is the correct definition. Sin I by sin R equal to mu 2 by mu 1. That only given as mu BA. Suppose mu 1 is the refractive index of first medium and mu 2 is the refractive index of second medium. Then sin I by sin R equal to mu 2 by mu 1. But mostly we studied mu equal to sin I by sin R. Is it so? That is when second medium is air medium. For air, mu 1 equal to 1. That is for air medium. First medium is air. This medium is air medium, for example. And second medium may be some other medium, glass medium or water medium, whatever. Then mu 1 equal to 1, mu 2 by mu 1 as just mu. That's why we studied this as mu equal to sin I by sin R. Mu equal to sin I by sin R. Okay. In there, mu 1 will be 1. That is medium, first medium is air medium. Okay. This is Snell's laws of refraction. Second laws of refraction is also called as Snell's laws of refraction. State Snell's laws of refraction, ratio between the sine of the angle of incidence to the sine of the angle of refraction is constant. That is equal to refractive index of second medium with respect to first medium. This is the Snell's laws of refraction. Okay. Can we move to next topic? Methods to determine refractive index of the medium. First one, mu equal to velocity of light in air by velocity of light in the medium. This is also called as definition for refractive index. That is mu equal to c by v. C is the velocity of light in air, v is the velocity of light in any medium. Okay. So mu equal to c by v. Mu is the refractive index and c is the velocity of light in air, v is the velocity of light in a medium. And mu value will be 1.5 for glass. For glass, mu value will be 1.5. Then from this you can find the velocity of light in glass medium. Very simple problem. Mu equal to c by v. Mu equal to c by v. Then here you want to find v only. Find v. Mu equal to c by v, v equal to mu equal to c by v, v equal to v equal to v goes there, mu comes there. So v equal to c by mu. And what is the velocity of light? 3 into 8 divided by mu 1.5. Simplify it. 1.5 how many times? 2 times. Then mu equal to 2 into 10 power 8 meter per second. This is the, sorry, VV, not mu. V equal to 2 into 10 power 8 meter per second. So velocity of light in glass medium is 2 into 10 power 8 meter per second. It is greater than velocity of light in air or less than velocity of light in air? Velocity of light in a glass medium is greater than velocity of light in air or less than velocity of light in air? Less than. Is it so? That is 3 into 10 power 8. This is 2 into 10 power 8. So it is less. And Another definition, mu equal to 1 by sin c. What is sin c means? C is a critical angle. C is a critical angle. Wait 1 minute. I don't. Okay. C is a critical angle. Where we are using this one means in optical fiber we will use critical angle. Critical angle will be used in optical fiber. Critical angle means critical angle is the angle of incidence in a denser medium corresponding to which the refracted ray just grazes the surface of the separation. How is that? Because from this also one question will be asked, one problem will be asked. That is, this is a two medium, this is a medium 2 and medium 1, and light is incident on the medium such that angle of incidence equal to critical angle. Then what will happen means light will refract like this. Okay. Then what is the angle of incidence? Sorry, angle of refraction. Angle of refraction is 90 degree. Okay. There is a question asked like this. That is at a critical angle in an optical fiber. What is the angle of refraction? Option A 0 degree. Option B 90 degree. Option C 180 degree. Option D 270 degree.